Hello everyone. So we're gonna try and make something like about as habit. We're gonna make a solar system that's like as similar as our to our solar system as possible. So yeah, very cool. Right now we're gonna start with a star, and now just for a comparison, just for a comparison, here's our star's habitable zone. Slightly far out. Here's our star's habitable zone. Why does the Earth keep getting placed? Oh my god. Give me a second. Delete. Alright, there we go. Anyways, our sun's habitable zone is around like this big. So we're gonna try finding a random star that can be like that. That was very clearly a smaller habitable zone by a long shot. Okay, wait. Habitable zone? Arsenal? Nope. Nope, that's way too big of a habitable zone. Still too big. Okay, that's decent. We're gonna try. We can maybe find something better. Though. Nope. 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 Alright, bro. Nope. Alright, we're going with HR 4656. Now, if we go to the star. Alright. This star is basically the exact same size as the sun, except for its radius. Its radius is smaller than the sun. Like, by. Let me do a comparison. Actually, it's a very similar radius to sun. This star's a good star to start with. Hey. Though the planets go very far out. Alright, let's do this. So, with our star, we need a random rocky planet to surface Mercury. Now, that seems way too big, so, this seems like smaller, maybe? Let me check. We might have to bring the radius down and... Oh, okay. We can bring the radius down way more, though, because... Okay, wait, lock the mouse, make it denser. Alright, there you go. That's Mercury now. Though it has to be gray, so, give me a second. I'm pretty sure Mercury has more silicon and iron still, though, but I don't know. Yeah, alright, so that's just basically Mercury, but that's that's it. That's the first one. Alright, Venus time. This planet better not be a habitable planet. We can't have a habitable planet. We need to make one that's a very similar size to Earth, like maybe here. Now it is technically in the inner Goldilocks zone, but here's the thing. We're gonna give its radius like that, and then like make its mass slightly higher. There we go. But here's the thing we're gonna do. Surface, atmosphere mass. Alright. This is we have to make it massive enough to actually hold an atmosphere like Venus does. There we go. That's like exactly the same as Earth. Right, what's happening right now? Alright, that's still low though, so because we have to make it. There we go. Wait, let's just check out how much more thick. That's still less thick than Venus's atmosphere. Yeah, like let me check how thick Venus's atmosphere is actually. Wait, right. Pause the simulation. Pause simulation. Where's Venus? Venus's atmosphere. Oh, okay, so that's way thicker than it needs to be. It's only like 94 times thicker than Earth's. Alright. Let's bring the atmosphere mass of this planet down a little bit. The average temperature is way too low, though. Like, we need it to act as a greenhouse effect. Oh, I forgot about rotational periods. Anyways, the atmosphere is going to be, like, bring it down a lot. Like, genuinely a lot. Like, maybe a little bit higher. Like that, yeah. Alright, let's see. It's nitrogen, but Venus's atmosphere is, like, mostly carbon dioxide. So, we're bringing that up a lot. 30, and now it should be a greenhouse effect. Let's add some methane as well, just for more greenhouse effects, but it's mostly made out of carbon dioxide. Let me pull up some stuff. It's made of water vapor, sulfur dioxide, mostly carbon dioxide, and a little bit of nitrogen and argon. Oh, okay, wait. Bring that down. As we're gonna multiply this up by quite a bit, and then nitrogen, that's already a lot. So yeah, there we go. That's carbon dioxide, and it's mostly carbon dioxide. So we're bringing the nitrogen down actually. But oh no, bring that down a lot. Holy crud! All right. And let's make the carbon dioxide like 80. Yeah, now it's actually like starting to look exactly like Venus, and now the average temperature is still negative 18.5, but there we go. We got it. And now it should be heating up. Give me a second. Oh, no, wait. It'll take a while. Yep, heating up. Oh, it might be heating up too much. Oh, it's heating up too much. Oh, God, alright. It's still going up. How many degrees Fahrenheit is it? Crap. I mean, it's stabilized now, I guess. Give me a second. It looks like it's glowing. It has a glow. That's how. Let me update this. There we go. Now we have mercury. Let's see how hot it is right now. Okay, that's not that bad. Still losing temperature though. Oh my god! All right, bring this stuff down. Bring the speed down. Okay, next up, we have Earth. We might have gotten. Okay, that's random rocky planet. I don't think that is. Give me a second. The star's habitable zone's bigger than that. Yeah. Dun, dun, dun. Stop shrinking! Habitable zone, stop shrinking! Oh my gosh. Look, Earth's habitable zone. It's like that. I feel like this could actually be cooking. Wait. We might actually be cooking with this. And Earth's habitable zone's like. Oh yeah, no, for sure. This one could actually work. Check it. Oh, this is the best. This is already so good. This is already so good. This planet already has water. I don't have to add its surface. It has an atmosphere that's slightly larger than Earth's. Let's take in it. Let's make it slightly smaller, but not that much smaller. And already it's very similar in size to Earth. I don't think I have to change that many attributes. Oh, its temperatures. Its temperature's actually good. Wait, let me check. It's Fahrenheit. That's a good temperature. That's a good temperature. Actually, wait. Already, let me check the life likelihood. It's in composition, isn't it? Alright. 48%. That's good already, but look. We're adding a magnetosphere to this one. Because this planet needs a magnetosphere. Like, let's make it like 3 times the Earth's radius. Like, just like Earth's is. That's a good magnetosphere. That's a good magnetosphere. Magnetic field strength. Give me a second. Because our magnetic field is. Oh, wrong one. BRB, let me go Google it. I genuinely don't think I have to change anything. This might. Overpowered. Wait, let's check its visual. It has liquid. It has no. Does it have vegetation? Wait, let me turn on the mic. Let me just check its surface map. Actually, we might need to bring the sea level a little bit lower. Yeah, it's a little bit high. There we go. That should be good. That's very similar to Earth. 44. Okay, I might have brought it down a little bit, but still, that's good. This is a good planet for life. I think this is actually like my best planet for life so far. I know it's not like. Alright, we're making our city lights, like, I love making my city lights blue because it looks so good. This is a good planet for life already. We might already be onto this. Alright, we're turning the magnetosphere off, but still. OP planet for life, bro. Alright. Oh god, that's gonna be like the very inner. Is it gonna be. If I fast forward sometime, will it be like. Will it heat up? Oh no, it's not heating up, it's staying! It's staying stable! Wait, hold on a minute, hold on a minute, hold on a minute. Is the life likelihood going up or down? That's my question. It's going down. What? Why? Actually, its Earth Similarity Index went up though, but we might actually be able to get it. Alright, anyways, next up is Mars. Which is gonna be. No, that's. Actually, no, 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 no. It's a random multiply Mars. There you go. This is actually. Okay. That's an incredibly small one, so, on to our gas giants next. It's about like fifth, about a half of the radius Earth, and obviously it does have some ice. It has atmosphere. Let's actually just make it conveniently one of Mars's atmosphere. Yeah, yeah, yeah. This is good. This is good. This is good so far. Now let's make its atmosphere red. Um, ice. Okay, that might be too high. Okay, okay. So 200 meters is too low. What have we learned? Anyways, what else have we learned? Average temperature has to go down a lot. Like, and I mean that okay, that's too hot. Bring it back up. Bring it back up. That's too hot now. Like negative 40 degrees, and that's where water starts freezing over. So that's what we want here. We want the water to start freezing over. How long will this take? How long will this take? And also what's it? I guess we take about a day. Anyways, we'll just wait for the water to freeze. Probably will happen soon, but color is gonna be like a reddish orange right now. So we're just gonna let's just add it. These are terrible colors for a Martian planet. Make it like red, like reddish orange. That's too orange. That's too that's too that's oh it's so bright and it's way too orange. That's way too red and it's too bright. Like that and like make it less bright. There we go, there we go. That's like tell me that's not Mars. Tell me that's not Mars. Like that's Mars. There we go. We got Mars. We got Mars. We got Mars. We got Mars. Alright. And I know it doesn't look like Mars, but it still is Mars. Let me check this rotational period of this one. One day. And its life likelihood is currently plummeted to 51. It's going up. It's going up. It's going up. It's going up, guys. Don't worry. We'll be able to see him even if we have a dead planet or two. We still have a life planet, and also going back to this, we're gonna do our next planet, Jupiter, which is very massive. So I want to see the habitable zone of Jupiter to make it. Yeah, it's not. There we go. Wait, that's good. That's good. That's good. That's good. And then there's a pretty big distance between them. Like Jupiter's farther away. Oh, that's boring. Make it at least 0.9% of the mass of Jupiter. Alright, play it, go back down a little bit. It's slightly bigger than Jupiter in radius, but slightly smaller than mass. That's still good though, I say. I say. So now, this planet has a rotational period of, bringing it down to hours, 9.5 hours. I'll let the moons later, but now Saturn is slightly smaller. Also, I completely forgot how to change the tilt on these things. Oh no, shoot. Which might have just launched. Why is its temperature so high? Did it just let. Oh, it just crashed into a planet. Hey. Oh, hey, the other one's still there. The other one's still there. It's just like still merging in. It's like a satellite that's flying into it. Okay, we don't got that yet. Okay, so delete. Anyways, this next planet is like, let me go Google how much Saturn is than Earth again. This is a pretty accurate size for that radius. It's just that mass needs to be lowered. Right? Can I lock the radius or not? Like, we're adding rings to this one though, and there we go. We've Saturn now, though its color is kind of off. It's like a palish yellow. They're all like palish yellows. So yes, that's looking like Saturn now. Oh, and also I need to go change Jupiter's thing. Jupiter's are either like fleshy colors or like a brownish color, not like a slightly brownish color. It's not like there we go. We got Jupiter now. Next we have Uranus, which oh yeah, it's 11 hours actually. I'm pretty sure hours 11. Right. Next up, we have Uranus. Can't even tell if it's gonna orbit anymore. Orbit. Which is more than which is almost triple the distance that Saturn is. So okay, this is not accurate at all. All right. Firstly, rotation period 17. There we go. But the mass of Uranus is bigger than the mass of Earth. Let me. All right. So I think I might have just paused the recording, but I finished Saturn and I added Uranus. But let me check how to get what am I doing? What am I doing? There we go. I'm gonna go Google how much more massive Uranus is than Earth. All right, back. There we go. We got it. Now, here's the thing. Its axial tilt has to be very large because it's Uranus, which has the axial tilt. I forgot how to do that, so let me go figure that out real quickly. Okay, I figured it out. 98 degrees. That's Uranus tilt. And also this doesn't look like Uranus, so custom. Oh, and also we have to do Uranus's composition. It's a slightly different composition than our other gas giants. Uranus and Neptune are the two gas giants which we're gonna have to edit the most. But Uranus also has its own rings. I forgot to add them for. I didn't add them for Jupiter because the Universe Sandbox literally doesn't have Jupiter's rings as an option. Because I don't think they do. Oh no, they do. Oh, they don't have Neptune's. And there we go. We have Uranus's rings. We'll add their 5 major moons soon. Wait, actually, there we go. Give me a second. I need to add rings to Jupiter as well. Anyways, time for Neptune. Actually, wait. Composition. It has more water, ice, and ammonia. Oh, what? Oh, wait. That was unexpected. All right, I don't have to change the composition of this at all. Orbit. Further. Now it's mostly bound to our good old friend Soar. I get this. I don't know. Dude, at this point, I don't even know. We'll do other features maybe in part 2, alright? Like, but for now, alright, that is way too massive for this. 4 times the radius of Earth, but the mass has to be like 14, 13. Slightly more massive than Uranus. This actually, Neptune actually does have a axial tilt, unlike, and this one I'm actually going to have to play around with. because it does have more water, ammonia, and methane ice. It's an ice giant, so it has things. Also, the methane's what causes its blue color, FYI. Just for you to know. Alright, so, bands, we're gonna make them blue. Uh, but we're gonna make them the correct blue. We're not making them this blue. We're gonna make them accurate colors. So, like here. Yeah. I know, shocking that Neptune's very similar. That Neptune and Uranus are the exact same color almost, but it's very sad for all the people who like Neptune for the color section. But yeah, Neptune and Uranus is the exact same color. I'm so sorry, everyone, for ruining it for you. Also, I think we might be able to still add rings to Neptune. To this, which is not. All right. Well. Alright, nope. I failed. But also, wait. Hold on a minute. Hold on a minute. Oh, there's rings. There's rings. There's way too many, actually. In fact, that might be too many, but whatever. We already gave Uranus a lot of we gave Uranus a lot more rings than it actually has as well, so, I guess you're welcome. Yeah, Uranus also has a fair share of rings. Alright, well, I guess this is the entire thing. Yes, I'll add an asteroid belt. Actually, yes, I'll add an asteroid belt. Add asteroid belt. Where is it? Add ring to HR. Okay, is it possible to undo this? We might need to bring everything in now. Actually, wait, no, 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 we don't, no, we don't, no, we don't. Firstly, what the hell is this? Oh, that's what it is. Alright. The only difference is that Oviachen is in front of the asteroid belt, but it still likely keeps the asteroid belt in check. Well, Nuston, okay, I don't even know at this point, man. It's barely in the asteroid belt. That's the only difference. That's good. That's good. I'll take it. This is our new system, except for the moon's part, because we literally have. All right, we're gonna start with Earth's moon because it's only one major moon. Moon, random moon. Okay, that might actually be good. And we're gonna make it around the same distance our moon is away from. Around. You know what? Screw it. That's gonna be good. Anyways, oh god, alright. Well, I'm pretty sure it ended up losing. I'm pretty sure it ended up stopping being a moon and it ended up becoming a planet. Give me a second. Yep, it's now a planet. Uh, explode. And. Oh, there we go. It just disappeared without a trace. Anyways, let's try this again. How about we? Right. Is it? Oh, I forgot to make it orbit. All right, that's what's going on. Yeah, there's a certain point where it stops orbiting, but this is not that point, so we're doing it now. That's the moon. I'm not bothered to really change the what does it look like? Okay, nope, I'm bothered to change the appearance. It should not be that similar to Earth. I'm gonna be fully honest with that. Mm, 0. The, where'd the how'd the sea where'd that come from? Hold on a minute. I'm pretty sure I just removed the sea level, man. Where'd that come from, man? Dude, give me a second. Um, delete 0. All right, there we go. Now we can add a little bit more water, but the moon does have does in fact have water, but doesn't have that much. Doesn't have enough to be shown on the surface. So there we go. And I'm not bothered to change its base color. Now this planet is literally just like we add it to raw. Actually, screw it. You know what? Random asteroids. That's how small Phobos and Deimos are. That they're random. That they're small enough to be random asteroids. That's how small. That's how small Phobos and Deimos are. Now, for reasons, I'm not gonna add every single moon to the gas giants because, like, I mean, there's way too many. 95 moons for Jupiter, 274 for Saturn, 28 for Uranus, and 16 for Neptune. So I feel like adding a random rocky planet for Ganymede would be good actually. And then we have smaller moons for everything else. Like that's way too small. But Io, Europa, Callisto. Oh, I'm not editing their attributes. It's stupid. And now we have our good old friend Nastas. I'll edit their attributes in the next part, okay? I'm just too lazy right now. Where'd the rings go? Where'd the rings go? Hello? Oh, I deleted every particle. That's right. That includes rings. So the thing with it is that shoot. Um give me a second. I don't have it memorized by how close the major moons of Saturn are. So after researching it, it's Mimas, Enceladus, Dione. Wait, no. Tethys, Dione, Rhea, Titan, Iapetus. Barely even bound to the star anymore. To the thing anymore. Schema even orbiting it anymore. Oh, it is. It's still orbiting it. Barely, but still orbiting it. Also, is that the rings back? There we go. Oh, okay, that's kind of lucky. Give me a quick second. Delete all particles, which includes the rings. All right, add, add. There we go. And let me add the rings back to the Jupiter thingy as well. That is not Jupiter. That's Jupiter. Oh, I'm gonna have to change these surfaces. And next is Uranus, which I'm gonna have the rings and do the moons at the same time, because, like, what's the point of doing it without the rings and the moons at the same time? Alright, give me a second. Well, I know Miranda's the closest. Alright, it's Miranda, Ariel, Umbriel, and it's Miranda, Ariel, Umbriel, Titania, Oberon, and I need to delete that. But yeah. Miranda, Ariel, Umbriel, Titania, Oberon. And now the only major moon of Neptune is Triton. It's hilarious. And also maybe we have to add the rings back to this one as well. This is slightly darker than this other thing. And boom, we're done with all the major moons. And I'm not editing their attributes right now, but this is the new solar system that I made. I need to add the asteroid belt back as well. Oh, I need to add the rings back. BRB. Right, there we go. We got rings. This is the start. Yep, we're here in the solar system now. And we're adding our asteroid belt now. Add ring. Now there is a planet that's like directly in it. That's the Saturn one, but still, we don't care about that. Alright, so let's do a tour for today. We have our good old friend HR4656 with our good old friend with our good old Mercury thing, which is a very high and a very hot planet. Jupiter is like it's stabilized at 8 of 14 degrees Celsius, or let me check it. It's Fahrenheit thing. 1,498 degrees Fahrenheit. It might be slowly rising, but still not even close. Its habitable zone is way out in Saturn. Actually, Uranus's orbit. That's how far it would have to be to have take only enough energy to be habitable. Now we have the Tibigori, which is just it's the habitable one. Let me actually check its habitability. It's definitely more than 50%, at least I'm pretty sure. 51.4 and 99.2% similar to Earth. Yeah, there's definitely life on this planet, I'd say. I got a good planet to start with. Awareness, the oceans haven't frozen over yet, but Mars, this is the Mars equivalent. 0.141% chance for life. Likely not habitable. This is the Jupiter one. No, this is Jupiter one is very big. Slightly bigger than Jupiter in radius, but slightly smaller than it in mass. This is probably gonna act like a Jupiter, but like orbiting around another star. This is the Saturn of the group. The amount of asteroids you see in the asteroid belt, man. Anyways, this is the Saturn of the group with 7 major moons as well as its rings. And then we have Uranus with its major moons as well as its rings. And then Neptune when it's in its actual colors. I know I made it slightly darker than Uranus, but they're the exact same color. Yeah, Neptune's the light blue just like Uranus with Trite. And also a stripe. But yeah, this is it. Boom, guys, we got it. This is the new solar system in the center. So I'm gonna like save it and then post it to Steam because why not? We're gonna update it in part 2. And there we go. We got it. Bye guys. I guess. See ya.